Okay, so hopefully you read this problem, and you got a state policeman who wants to figure out if people that drive red cars speed more than other cars. So, this whole thing about rolling the die is the way that he's going to take a random sample. So he doesn't test the speed of every single car out there, just the ones that roll a 5 or a 6. So anyway, he figures out that 18 out of the 28 red cars that he saw were speeding, and 75 out of the 205 other cars. So we are going to do a significance test on this one. All right, so let's take a look at what our proportions are. So what are our hypotheses? Because that's when we use hypotheses is in a significance test. So the null hypothesis is, of course, no difference. If you take the proportion of red cars and subtract the proportion of other cars, you're going to get 0. And remember, it's not the sample proportion, it's the population proportion. So it'll be for the whole population. And let's see, what's our alternative hypothesis? Is going to be that if you take the proportion of red cars and subtract the proportion of other cars that are speeding, you're going to get a number that is bigger than 0, right? So more of these people are speeding than those people. Okay. And for this, we're going to do a two sample z-test because it is a proportion. Okay, so there's that. So this is a test of significance. Let's not forget that. So that's the one that we need, that new standard deviation where we combine the two samples. The reason that we do that is we just want to have a more accurate account of who is speeding. That's the best way I can describe it. So what we're going to do is we're going to say, what is it? It's, whoops, wrong color. There we go. We are going to get the combined proportion. So what do? We say, well, 18 plus 75 over 28 plus 205. That's going to be our combined proportion. And when you add them up and divide, you get 0.4. So, what do we do with that? All right, I think I need to go another slide. Hold on a second. Okay, we are going to use this wombo combo here to get our standard deviation. So what's the standard deviation? This is still a proportion, right? So we're going to use this since it's a significance test. So it's going to be 0.4 times 0.6 times the first sample, actually divided by the first sample size, right? And then the same numbers, 0.4 and 0.6 divided by the second sample, which was 205. Okay. Crank that number out, and what do we get? .099. So that's our standard deviation. So here's our z-score. It's like this. And we're going to put, so the number that we got minus, right, is the two proportions, minus the number that we expect, which is 0. Okay. And that's the number we're testing against, divided by 0.099. So then when you divide that, you get 2.73. 2.73. Now, what does that mean? we are way up here. 2.73 standard deviations above the average. So what is the probability that we would get a number bigger than 0, like that? So essentially we're saying the fact that we got these two very different proportions, what is the probability that that would happen? That's that probability right there. So what we need to do is normal CDF for 2.73 to figure out what is the probability that we would get that. So I put in a normal CDF, negative 1,000 to 2.73, and I get 0.9968 something, right? And then I'm going to subtract that from 1, because that's this area. 0.9968% of this area is there. What's left over? So we minus 1, and we get 0.003. That's that area, 0.003. What we're saying is, if it's true that there's no difference between red cars and other cars, the fact that we got these two proportions so different would happen only 3 out of 1,000 times. Okay, so what's our conclusion? Because, and this is an alpha level of 0.05, because our p-value is so much lower than our alpha level, we are going to reject the null hypothesis in favor of the alternative hypothesis and say, yes, we have sufficient evidence to say that red cars are speeding versus the other cars. Okay, there's that one.